Good evening, ma'am. Today I will explain the working mechanism of a centrifugal pump and discuss the function of each component shown in the diagram. So later on, I will flash this on the screen. A centrifugal pump, it is a type of dynamic pump that uses the principle of a centrifugal force to move fluid. The main idea is that the pump converts mechanical energy from a motor into kinetic energy and then into pressure energy of the fluid. So here's how it works step by step. I will flash on the screen. So first, the fluid intake. The fluid enters the pump through the intake or suction pipe here, which is connected to the eye, the center of the impeller. So here's the impeller. At this point, the fluid is at low pressure. Low pressure pa siya. So the rotation of our impeller, so you know that the impeller is connected to our drive shaft. So here is a drive shaft, which is rotated by an external motor. So when the impeller rotates at high speed, it throws the fluid outward from the center toward the periphery using a centrifugal force. This process increases the fluid's velocity here. And after the fluid is pushed outward, it enters our volute casing. Our volute casing, which has a spiral shape, so as you can see in the diagram. Inside the casing, the kinetic energy or high-speed movement of the fluid is converted into pressure energy. So finally, the pressurized liquid is discharged through the discharge nozzle to the delivery pipe for use. So we have different parts, as you can see here in our diagram. First, we have our drive shaft. Our drive shaft, it transfers the mechanical energy from the motor to our impeller. And next is our ball bearing. Our ball bearing supports the drive shaft and reduces friction during rotation and ensuring the smooth operation. This is our ball bearings. And next is our enclosed, our bearing house. This is our bearing house. Bearing houses. So our bearing house acts as a support base for the entire bearing assembly, so keeping it stable. And our impeller naman, this is the heart of the pump. So it is a rotating component with vanes that impart kinetic energy to the fluid, pushing it outward. Next is our shaft seal or stuffing box. So our shaft seal or stuffing box prevents leakage of fluid. You can see this is our shaft seal here. It prevents the leakage of fluid along the rotating shaft. So it also helps maintain internal pressure and avoid air entry. Next is our wear ring. Our wear ring installed between the impeller and casing. It is to reduce wear caused by friction and to control leakage from the high pressure side to the low pressure side. Next is our volute casing. Our volute casing has a spiral-shaped casing that collects the high velocity of fluid from the impeller and gradually reduce its speeds, converting into kinetic energy into pressure energy. Next is our intake or our suction. This is the entry point for the fluid into the pump. So it ensures the fluid reaches the impeller smoothly. And lastly, our discharge. This is the outlet through which the pressurized fluid leaves the pump for delivery. So in short, the centrifugal pump works by drawing the liquid into the eye of the impeller, spinning the impeller to increase liquid velocity, and converting velocity into pressure inside the volute casing, and delivering the fluid under pressure through the discharge. So this design makes centrifugal pumps suitable for moving large volumes of liquid efficiently. So this is our centrifugal pump. And that concludes my discussion about the centrifugal pump and its parts. Thank you so much, Mom. Have a good night.